Hi, this is Doug Sparks from M2M Technology, and today I'm going to talk about MEMS supply chains. And at MEMS2M Technology, we really focus on helping our clients adjust to changes in MEMS and sensor supply chain and help them with various aspects of the supply chain or development process that they may need a little assistance in. Now, MEMS stands for Micro Electromechanical Systems. It's a subset of the semiconductor industry, and as such, it has a similar supply chain. You know, there's wafers, there's wafer fabs, there's fab equipment, you have to do packaging, there's IP, there's funding requirements. All those things form what we call an ecosystem, and linking those various parts together from concept design through high-end manufacturing are the elements of the supply chain. Now, a MEMS product typically has three physical components. You have the MEMS or micro machine chip. You have a CMOS ASIC. These can be bonded to the MEMS chip. And then you have a package. So the chips are put into a package. This can be a cavity package. It can be ceramic, etc. They're assembled together. And then don't forget, they got to be tested. So those are the components of MEMS products. Now, prior to 2020, 2018, so the traditional things you thought of when you thought of as a supplier or a buyer were, what's the cost and quality? Can they go all the way from the foundry to the OSAT to the customer? You know, are we going to use just-in-time lean suppliers? Are we going to need warehousing? Are we going to have to dual source? And then there were some regulatory things, export controls, tariffs, VATs, CFIUS, ITAR if you're in the military, and then is the product dual use? So those are the conventional things that buyers and purchasing agents worried about, as well as operation people, when they're developing and manufacturing a MEMS product. However, COVID, geopolitics, and new technologies have changed the traditional semiconductor supply chain. If you look at MEMS fabs worldwide, you see they're basically everywhere. There was a big lead in the US back in the day when automotive and blood pressure were the main markets. Japan kind of got into that act with automotive through Nupendenso. Of course, Bosch developed European automotive devices. And you saw this period where the lead went from North America to Europe. And I would say Europe still is in the lead with ST Micro, Bosch, Silex, etc., Infineon, cranking out a lot of MEMS products and doing a lot of manufacturing. If you look at some of the more recent Yole reports on MEMS foundry rankings, you see these are pure foundries. You see companies like Silex, Teledyne, which is in Canada, TSMC, XFAB. Those are the big industry leaders in foundry work for MEMS. Of course, companies like Bosch and ST, they make their own chips. They're an integrated supplier and have their own foundry, so they're not shown on this graph. Now, one complaint startup companies have is that they can't get into these big fabs. They don't have $1 million to place the first mass set order, or maybe the lead time is too long. So when you're doing development at a startup, we found that you need another, there needs to be another kind of parallel supply chain for small companies and startups that usually uses smaller diameter wafers that are amortized or using some new idea to commercialize MEMS products. And even for big products, you typically have sort of a concept and development phase. You do some prototyping before you go to production. So even for a high volume device, you don't need high volume number of wafers or lots to get through these multiple stages: concept development, prototyping. And so in those volume realms, startup development, as well as markets like industrial, medical, and aerospace, smaller foundries can still play a role. I thought one of the more interesting new foundry concepts is Inch Fab. I've worked with them some, and they've really rethought the MEMS foundry part of the supply chain. So they use smaller wafers, so they have low capex, custom-made tools for their foundry, which is in Sunnyvale. Um, and they're really they're faster to market for a startup company. Their prices are usually 50% less than a big foundry, and so they can dramatically lower startup costs and development costs, and kind of shore up that part of the supply chain that was really hurting in the last few years. Now, if you look at CMOS fabs, as we know, Asia just dominates CMOS foundries. Think of TSMC, Samsung, UMC, SMIC, uh, particularly really small nodes. Now, MEMS devices don't use these small nodes. They're usually 90 nanometers, maybe 65 nanometers. So a lot of this capacity in Asia is not particularly set aside for MEMS. MEMS is a mature family, and could be run almost anywhere in the world. You're going to see, as the demand for foundry products have kind of died down in 2023, you're going to see some of the fab capacity open up for MEMS ASICs, I think, this coming year. So smaller companies that couldn't get access to a big player may find they're more amenable to taking on lower volume projects. Now, MEMS manufacturing in Asia really began with the OSAT, with the assembly and packaging. And much like traditional ICs, this started several decades ago. A lot of development has occurred in that region for package and assembly and test. And big companies like Amkor and ASIC, if you're running a high volume consumer MEMS device, you're probably getting it packaged at one of those firms. So still, Asia is the center of gravity for not only CMOS foundries, advanced node CMOS foundries, but they're also kind of the center of gravity for the packaging and OSAT function. Now, MEMS packaging is notorious for being much more complex than the traditional semiconductors. You'll see high reliability devices in, say, the aerospace area are still using ceramic and metal cans, and they've been doing that for 4 decades. Industrial devices using extremely large, say, an industrial pressure sensor, they're selling this pressure sensor for $10,000. And it just has a single piezoresistive or capacitive pressure sensor chip in there, but it has to be housed in this corrosion-resistant environment with, very large, manually adjustable input and output panels. If you go over to medical, you think of implantable devices, heart implants, brain implants, diabetes monitoring. You think of wearables, whether it's rings or patches. These have to be wireless, sometimes batteryless. So you can see just the diversity of MEMS packaging for different markets. Now, again, MEMS startups can't afford the ASIC foundry. They may not be able to afford, a injection molded package project. So what we've seen in the last few years, and I've done this myself at startups, is the use of 3D printed packages. Printing these cavities out of a 3D printed plastic. Maybe instead of an ASIC, you use a printed circuit board and an FPGA. So your core device, your MEMS chip, is mounted on this circuit board, wire bonded to the gold emulsion circuit board pads, then use an FPGA to program it. So that's one way that small companies and startups can avoid the capital expense and the big upfront NRE of a traditional ASIC foundry or packaging house. Now let's just kind of take a quick glance at the top MEMS companies. This is as of the end of 2022. You still see Bosch, you still see STMicro up there with their inertial sensors, their pressure sensors, but you're also starting to see the rise of communication type devices, filters, oscillators, switches, F-bars, timing devices. So I think it's an interesting play where some of these companies, which are maybe US or Asian based, are starting to rise up this chart and join the ranks of the top 5 or top 10 companies in the world. Now I want to just kind of dive into some of the infrastructure that makes up the global supply chain for MEMS, and just kind of go country by country. Just a few examples. I already mentioned Europe. Europe certainly is the lead region. You've got Germany with Bosch, X-Fab, Infineon, Italy with ST Microelectronics, Sweden has Silex, and then you've got really critical MEMS fab tool suppliers, wafer bonders, deep reactive ion etching, all coming from this region originally and still doing manufacturing there. Japan was an early participant in MEMS, particularly in automotive pressure sensors and accelerometers, gyros, and they still got a lot of capacity. I mean, Sony is cranking out, most of the world's microphones, MEMS microphones. You've got TDK owns TDK InvenSense and a lot of other sensors, magnetic sensors, for example. You've got Silicon Sensing. You've got some really interesting companies like Nagano Kaiki. I worked with them years ago, where they're just fabricating stainless steel pressure sensors, a chip at a time in their own dedicated wafer fab that processes nothing but stainless steel. No silicon involved other than the polysilicon films they deposit. So a lot of interesting capacity in Japan, and their government's pouring money into that to support their supply chain. South Korea. When I think of South Korea with respect to the MEMS ecosystem and supply chain, I think of the high volume packaging, which is ASIC and Amkor. But you've also got to think of Samsung's foundry, and you've got to look at some of the other stuff they're doing to come up with new foundries, come up with new concepts, and the government is just pouring billions and billions of dollars into the ecosystem there. Taiwan's always on the top of anyone's list when you're talking about just foundry dominance, CMOS foundry dominance. And they're also the leader in 200 and now 300 millimeter MEMS foundries. Of course, they got the start with CMOS imaging sensors doing bonding and etch back a decade before they got into MEMS. So they've been doing high volume 200 and 300 millimeter silicon sensor wafers for a long time, cranking out thousands and thousands of wafers. Interesting to see, a couple of years ago, they announced that they were doing 300 millimeter 12-inch MEMS wafers. So look for that moving forward, this shift with extremely large MEMS devices, like maybe these ultrasound arrays or LiDAR chips, things like that, maybe going to 300 millimeters. Of course, China is involved in this. They do they make a lot of devices there. I've been involved in that industry for over a decade. Pressure sensors, inertial sensors, flow sensors, etc. Now, a lot of their products are still imported, or they maybe import the wafers. For example, Infineon pressure sensors, shipped into the Shenzhen area, are packaged up there in China. But again, they have capacity 150, 200 millimeter MEMS wafer fabs. And then kind of an emerging country that needs to be noticed is Malaysia. They've always been strong in OSAT. They package 12% of the world's ICs. We've got Silterra, which trailblazed piezoelectric MEMS foundries, who just recently added CSOI, the COSOI process from Achmetic. So Foxconn is building a CMOS foundry there. They're going to add more front-end capacity. That was just announced this year as well. Okay, now MEMS supply chains have not been hit hard by the export controls that we've seen with advanced node semiconductors. So we haven't talked a lot about changes, reshoring, friendshoring in the MEMS field, but it's definitely in the works. Think of dual-use MEMS devices or sensors that could come under export controls, and they do. I mean, you can't sell advanced gyroscopes overseas from the US without getting permission. A lot of the ADAS sensors, the drone sensors, are almost military grade. So look for inertial devices, infrared sensors, for example, that could be used in targeting, things that can be used in drones, maybe LiDAR, 5G, 6G actuator filters, resonators. These may get on the export control list, and you've got to think of your friendshore and nearshore options for the MEMS supply chain. So just to summarize, ASIC foundry, they've added a lot of capacity. It's going to keep coming online through 2025, and this will be there will be a lot of mature node capacity, particularly in China, coming online. And if you're going to keep working in MEMS, you're going to want to think about migrating down to like 28 nanometers, because that's where most of the fab capacity is coming online at. So moving away from 65 or 90 nanometers in your ASIC, the mature nodes, maybe down to 45, 28 nanometers. Virtually all high volume MEMS fabs right now are at 200 millimeters. There have been a few companies like TSMC and Bosch that are doing 300. MEMS startups, though, can't afford this, and they need alternatives. And that's where some smaller diameter foundries can come into play, whether that's MEMS, ASICs, or even packaging. Export controls have not hit the MEMS supply chain yet, with the exception of, say, aerospace, defense, and industrial niches. But there is a push in the US to include mature nodes in regulations in 2024. So there could be an impact there in the future. So thanks a lot for listening. If you have any problems related to this, if you have any questions or any projects that need to be dug into, contact me, because that's M2N's technologies specialty. Thanks.